Look at any major global port, and you see a physical triumph of logistics. Cranes, containers, and cargo ships operating in a tightly choreographed sequence. But behind the physical movement of these goods is a less visible, equally critical architecture, the architecture of time. To maintain synchronization across a global supply chain, an organization has to map its business decisions to specific points in the future. If a team coordinates the wrong decision on the wrong timeline, the physical supply chain breaks down. This brings us to the formal concept of the planning horizon. In supply chain management, the planning horizon is defined as the future time span over which an organization plans, makes decisions, and commits resources. The primary purpose of this framework is to align those organizational decisions with time-based uncertainty. It creates a structured boundary, determining exactly how far ahead planners should look when setting inventory targets, booking freight, or designing a new factory. A planning horizon is not a forecast. A forecast attempts to predict what the market will do. The planning horizon defines the strict limit of what the business is willing to commit to in response to that prediction. A common operational mistake is assuming a planning horizon is dictated by calendar convenience, setting a 12-month boundary simply because that is the default view in the enterprise software. In reality, horizons are governed by the reversibility axiom. The length of a planning timeline is structurally defined by how easily the resulting decision can be undone. Consider the difference in impact. A decision to build a new manufacturing plant requires massive capital, takes years to execute, and cannot be easily reversed if demand drops. Conversely, a decision about which specific order to run on a machine today is highly reversible. If a part is missing, the shop floor can sequence a different order immediately. The scale of the consequence dictates the necessary look ahead. High-impact decisions demand a distant horizon to allow enough lead time for execution, while highly reversible decisions require a much shorter, tightly focused horizon. Structuring decisions this way turns the planning horizon into a risk management tool. It forces leadership to protect long-term capital investments from being derailed by short-term market noise. Because a supply chain requires both rigid, long-term capital investments and fluid daily adjustments, a single timeline is useless. Instead, organizations use a nested architecture, running 3 standard tiers of planning simultaneously. This chart maps nested planning timelines. On the left is historical baseline data. To the right, the orange strategic horizon governs multi-year commitments. Inside that, the green tactical horizon drives sales and operations planning. Finally, the red operational horizon handles precise daily execution. These 3 layers must fit together cleanly. The daily production schedule must add up to the monthly tactical volumes, which must align with the multi-year strategic network capacity. Warning tone. When these layers drift out of alignment, the system fractures. Strategic intent is entirely lost in the friction of daily execution, and the company ends up firefighting its way through the week instead of executing a plan. This plots plans by review frequency and complexity. The bottom left factory plan demands extreme precision and daily reviews with zero flexibility. Conversely, the top right S&OP and profit plans involve high complexity. They are reviewed monthly or quarterly, trading immediate precision for broad flexibility. If leadership applies the wrong horizon to a problem, the results are destructive. If a strategic horizon is too short, the business will be caught constantly redesigning its network, reacting to momentary demand spikes by opening and closing facilities at a massive financial loss. Conversely, if the operational horizon extends too far, planners sequence daily machine tasks based on unreliable 6-month-out data. This floods the system with noise, guaranteeing chaos on the shop floor when the actual orders inevitably differ from the distant forecast. Each horizon length supports different decision rights, strictly calibrated to the reliability of the data available at that distance. The core logic here is a mathematical reality. Uncertainty climbs exponentially as time extends into the future. Because of this, supply chain theory dictates that decisions should be deferred to the latest responsible moment. This combats forecast decay. No matter how sophisticated the algorithm, predictive accuracy reliably degrades the further out you look. The business has to continuously update its plans as time moves forward and the data resolves into focus. This is exactly why different horizons have different review frequencies. A rolling monthly update for the S&OP allows the business to adjust its posture without needlessly tearing up the foundational 10-year strategic goals every 30 days. The ultimate goal of a long planning horizon is not to perfectly predict the future. It is to secure enough visibility and secure enough resources so that the execution teams have the agility they need when the short term arrives. To function, a planning horizon must be anchored to the physical constraints of the real world. As a rule, an organization's planning horizon must be longer than its longest supplier lead time. If a critical component takes 9 months to source, a 6-month horizon guarantees a stockout. Once the horizon is set, planners use structural barriers called time fences to protect the execution teams from constant meddling. In this schedule, vertical time fences divide the horizon into control zones. The immediate block is the frozen zone, where no changes are permitted. Next is the slushy zone, allowing minor adjustments. Finally, the liquid zone is highly flexible to new demand. These zones act as a firewall. They prevent a sudden short-term spike in sales from overriding the long-term production strategy and throwing the entire factory into costly overtime. Time fences deliberately introduce friction into the system, perfectly balancing the factory's need for strict stability with the market's demand for agility. It is crucial to separate the concept of a planning horizon from lead time. Lead time is simply how long a specific physical process takes to complete. The planning horizon is the conceptual scope of your future intent. There is also a persistent fallacy that longer horizons automatically equal better planning. Pushing an operational plan out past the limits of reliable data does not create a deeper strategy. It just creates fiction. In fact, the current trend in supply chain management points in the opposite direction. Extreme market volatility is pushing organizations toward digital replanning, relying on sophisticated tools to run shorter, highly accurate rolling horizons that update constantly. To maintain a functional supply chain, timelines must be consistently nested, mapped to decision reversibility, and protected by time fences. And the hard boundary remains. Your horizon must reach further into the future than your slowest physical constraint. Ultimately, mastering the planning horizon is how a business translates abstract multi-year survival goals into the exact number of units a machine needs to produce by Tuesday afternoon.